Earlier this year, we launched our most powerful product to date, Klimax Solo 800, a superior performance mono amplifier that outperforms larger rivals.
We have brought out the Solo 800 in response to some requests that were made to us by our US dealers and retailers who were finding that quite a lot of customers were asking them if we had any larger monoblock power amplifiers. So we have been very successful at selling our Klimax Solo, which has been an excellent monoblock power amplifier for years, over 20 years now, and it's a superb performing amplifier, but it's limited to around 500 watts and 84 ohms. We were being asked if we could come up with an amplifier design which would be able to drive a lower impedance loudspeaker, a much larger loudspeaker. So we decided to go away and design a large monoblock power amplifier which would be able to drive down to 2 ohms and which would no longer require a cooling fan, and we'd be able to remove the heat using natural means. And so we came up with the Solo 800 design. So the Solo 800 is what we have been calling a cool running amplifier. So what we mean by that is we have done everything we can to ensure that electronics are sitting there at a very comfortable temperature. We have designed it with these relatively tall fins up the side, which have been designed to be just tall enough to ensure that they always are able to remove all the heat from the amplifier, even when it's working at its absolute hardest, without requiring any kind of forced air. So the idea is that the very hot or potentially hot output devices are all arranged at the bottom of the heatsink, and as the hot air rises, it allows some convection, natural convection of air up through the fins and removes the heat very nicely from the amplifier. We use a similar kind of principle inside the amplifier. There are devices on the inside of the circuit board which drive the big output devices, and they also need to have heat removed from them. So we have vents in the base plate, and then we have this very elegant vent on the lid, and as the hot air rises through there, it sucks air past the circuit board and cools the driver devices. At the same time, we're also using the Utopik with its very high efficiency, and also variable voltage rails, which ensure that when the amplifier is not working very hard, we don't have excessively large voltage rails across the amplifier. But as soon as there is any need for a larger rail, the voltage rails increase. And by doing that, we ensure that the amp runs as cool as it possibly can at all times. And a cooler running amplifier means cooler electronics and higher performing electronics. So the Solo 800 has our largest Utopik power supply inside it. So for over 20 years at Linn, we've been using switch mode power supplies to make sure that we have power supplies that generate switching noise which is so far beyond the audio band that it can never end up being heard by anyone. And at the same time, we benefit from a switch mode power supply's natural ability to remove mains related noise, so that we have none of the 50 or 100 hertz, 150 hertz noise that tends to end up in the audio band from a linear power supply. At the same time, we benefit from the fact that a switch mode power supply has better control over the output rails. Much like for the linear amplifier, there have been a lot of advancements in electronics over the 20 years since we've been making switch mode power supplies. So we wanted to try and benefit from some of that in the Utopik power supply. So the Utopik power supplies take advantage of resonant switching, softer switching, which ensures that the large switches inside the switch mode power supply are turning on and off when they have zero voltage across them by using resonant circuits to ensure that that voltage falls naturally. So by doing that, we have minimal switching noise being generated by the Utopik in the first place, and the other benefit of it is that it is a much more efficient power supply and therefore cooler running. At the same time, the Utopik power supply also has a power factor correction unit inside it, so we are ensuring that we are a very good citizen on the mains and we are not injecting harmonics back into the mains, and at the same time also getting very nice isolation between the mains, any variations in mains voltages, any variations in mains frequencies. So our Utopik power supply provides very nice isolation from any extraneous noise. At the same time, the Utopik power supply has also improved the switch mode's ability to control the rails under very heavy loading conditions, so that modulation on the rails is absolutely minimal. So when you combine that with the linear amplifier, very high power supply rejection ratio, you really see very little harmonic distortion caused by that mechanism. Adaptive bias control is a technique that we have recently introduced at Linn. We've started in the 360 loudspeaker, which has been very successful. So we have it in the Solo 800 in much the same form, really. Traditionally, linear power amplifiers, which consist of 3 main stages. They have a sort of differential input stage. Then they have what's called the voltage amplifier stage, which takes the input conditioned stage and multiplies the voltage up and does the actual voltage amplification. But the first 2 stages are very low power stages, and it's the output stage that actually provides the power into the loudspeaker. So the output stage doesn't have any voltage gain, but it must add in the current. So the way that happens is with 2 sort of sets of very large output transistors. So we have a kind of upper set and a lower set. And the upper set work during positive voltage cycles, and the lower set work during the negative voltage cycles. So what that essentially means that only one set is delivering the main sort of output power at a time. So traditionally there are different classes of amplifiers, which most people may have heard of. So we have Class A power amplifiers, and a Class A power amplifier, they actually have all of the devices on all of the time. So what that means is that what's called the bias current through the upper and lower devices must be larger than the amount of current you're trying to deliver to the loudspeaker in order to make sure that the upper and lower devices are always on. However, that becomes really impractical, because what that means is that you must have that current flowing, or that very, very large current flowing through all the devices all of the time, and you just end up with something that's absolutely roasting unless you're going to stick to very, very low power levels. So any amplifier that runs properly Class A over part of its power range, you'll find will switch to Class AB at above a certain power, giving quite a nasty interchange between the two usually. So what most people do is implement something called a Class AB amplifier. So a Class B amplifier is an amplifier where you only have the top devices on during a positive cycle and the bottom devices on during a negative cycle. And then your problem is, well, what happens when you're switching from the positive to the negative ones? You've got to get that switch over between all the top devices on to all the bottom devices on to be absolutely seamless, or you end up with what's called crossover distortion. And it's really not possible to get a beautiful, seamless transfer between them. So the answer is to inject a little bit of current through all of the devices when you don't have any signal present, so when you're close to 0 volts. You've got upper devices on and lower devices on. And what happens is that as the signal moves through a positive cycle to the point where the output current is larger than that bias current, then the bottom devices will all turn off. And then as it gets back towards 0, the bottom devices will all come back on again, and for a little while, for a wee instant, the top and the bottom devices all conduct. And then as the signal goes further lower, the top devices will turn off, and the same thing will happen in reverse. So that gives us what we call a bias current. And there is such a thing as an optimum bias current, which gives the minimum distortion in that changeover from positive to negative. So the idea with a Class AB amplifier is to try and set up that bias current and hold it there regardless of anything that happens to the amplifier, like temperature drifting or aging of the devices. So with adaptive bias control, what we do is we measure the bias current in the output stage all the time. And we digitize that measured current. We feed it to an FPGA, which is like a sort of very basic computer, really, you might say, which does a certain amount of signal processing on that information. And from that, we generate a bias voltage through a DAC, which is then applied using what we call a floating bias circuit to the bases of the big output devices, and we hold that bias current constant over all conditions, all temperature ranges, and throughout the life of the amplifier. And by doing that, we get really tight control of the bias current and very low crossover distortion.
So when we were designing the amp, we started first with what it needs to be from a cooling requirement. How big does it have to be? What's going inside? So from there, we could work out what we want to do with that design to refine it, to give it some detail and elegance that matches externally what the amp is doing internally. So we've got that detail and precision that matches what it's doing with the audio signals that are passing through it. One of the big things we focused on during the design process was the design of the heat sinks on the outside and how we could manufacture those and produce those best to fit together into the assembly process to give us what we needed from a cooling point of view, and also to give us the precision we wanted for the angles and the lines that are there. With the length of the fins that we have on the heatsink, we tried going with extruded heat sinks to start with. We found that a much better solution for us from this was to actually create these heat sinks from solid billets of aluminium. So we're machining these deep grooves in between the fins that allows us to get the cooling we need, but also to get the precise sizes, the precise angles and finish that we want on there to create the aesthetic that we want from the product. That goes from the slight taper that we have from back to front, the way the bases of those fins disappear underneath the lid of the product into kind of the dark shadow under there, to the smile cut that you get across the side, where every fin is cut at a slightly different angle. So from the front you get this slight wave going back to front, but from the side of the product you get this smile curved cut, which harks back to other products that we've done all through the years. On the lid of the product, we wanted as well to be able to take something that's functional, like the venting that you have to have there. We need that airflow through the middle of the amp to cool the components. But what can we do so it doesn't appear just as some vent cuts on the top of a product? So we take something functional and we turn it into this kind of framing cut that runs around the lid that nicely focuses in on the logo that's then cut into that centerpiece of the lid there. The design of the amp's broken down into several pieces, all of which we machine in-house, so we've got control over the finish of them, the exact fit and tolerance of them, and the design was also broken down in such a way to make it a much more manageable thing to work with all through our process as well. So when we're machining these parts and handling them, right from the cutting the metal process, all the way through anodizing of the metal for the finish, and then through the assembly process, each piece is broken down to make it much easier for our workers to lift, to move, to assemble into a final product. That's then carried through into the final product, reducing the weight as far as possible within this design, including handles when we ship it to make it easier to be installed in a house as well. The front of the amp's the real focal point of the design. The two different colour options, the silver front plate or the black front plate, the grooved detail that we have running on the top section of the front plate ties in with our Klimax DSM, with the lid on that, and it's got that precision and accuracy cut into it with this kind of gradiated pattern of those grooves that develop from the very finest at the top to something that becomes more visible as it runs down to where it intersects with the roundel in the middle of the product. At the very heart of it, we've then got this kind of beating heart with the real detail in there. Again, it's got a very close link to our Klimax DSM's dial, except on this it's sunk into the product with a much thinner piece of glass on the front, which is really highlighting the lights, the steel, chrome and brass parts behind it. We have the 100 LEDs there which light up, and you have control over the brightness for when it's sat in your room, but then we also have that which lets us give a bit of character to the amp as well. So from when you turn the amp on and it breathes into life with those lights on the front, through to when it's going into its standby mode and they have the playful animation as it's going in and coming out of standby as the lights bounce back and forth. You've then got the detail of this brass, which has the kind of pop of colour that it brings to the overall design in the front there, and that's etched with our details as a company. We're then right into these very fine grooves that get continued right in the middle, leading into where our logo's illuminated at the very centre of the amp, front and centre as you're sitting in the room.
The Solo 800, as I think we may have mentioned elsewhere, we wanted to take advantage of more recent developments in electronic design and also more recent improvements in electronic components. So what we have here is the output stage of the Solo 800 has 8 pairs of the most linear high-performing transistor that we can possibly find. So we found transistors which have superb flat current gain with output current So we are using that transistor and we're using 8 of them in parallel, which means that each one of them sees only 1/8 of the output load current, which really leads to them producing very little distortion, and also means that they are sharing the heat very nicely, which reduces the stress that's on the components and the amount of heat-induced distortion that comes from other effects within the transistors. On top of that, we have also done everything we can to linearize each stage within the amplifier, through the differential input stage, through the voltage amplifier stage. So a selection of techniques we've done to implement that are a triple emitter output stage, which really increases the open loop gain in the amplifier. It reduces the output impedance of the amplifier. We have also introduced a kind of global error correction loop, which also has very high open loop gain, and that takes any residual distortion that does remain on the output of the power amplifier and brings it down still further. And it's really a combination of all of these techniques that have led to the very, very low distortion levels that this power amplifier produces. So we've been very, very pleased with the results.
Klimax Solo 800 as a whole is the epitome of efficient, consistent and accurate circuitry design. Visit the link in the description to book a demo with your chosen Linn specialist and hear the difference for yourself.